Okay, so UKMARSBOT started life as basically our attempt to do a pick 1-2. I don't know if everybody knows about the pick ones kit that we had for a very long time. The idea was to replace that so we started in about 2017 designing this thing, and it shares a lot of goals with the UKMARSBOT. So it was designed to be able to do the line follower and the maze type things in a very similar way. It had multiple CPU carrier boards. So this is the main PCB, and the thing above it is actually an extension board for a BBC microbit, which was very popular at the time, but seems to have vanished into nowhere since then. So it first ran in the trials around the outside in 2018, and that's about as far as we got with it. Basically, what happened then was that we decided as a group to create the UKMARSBOT. So at this point, there was no UKMARSBOT, so we decided to really go in behind that and try and see what we could do with the development of that. So we stopped doing anything. So what happened then was that the UKMARSBOT got put together and the software was created. So we had this mouse which wasn't finished, it would run, but it didn't do mazes or anything. So we decided to put that software into this mouse because it's very, very, very similar parts on it. It uses the same gearboxes, the same motors, the same encoders, and all the other bits, although they're different, they're just replacements for the various bits that are on the UKMARS. So it has a power stage to run the motors, which is an H bridge. It's different to the UKMARS one, but essentially it's the same. And it also has built-in sensors. It ran initially as Mavis. I think the first time we ran it was at Hazelmere about 2 years ago. It then ran again as Mavis in Portugal, and then during the summer we decided just to try and popularise the UKMARSBOT, that we would do some modifications to it and created HAL as we've seen with it. Okay, so that's the two schematics, and although the HAL one is a very different style, because I will say that Jim actually created the whole of the PCB and everything for this mouse, but if you look very carefully you can see all the same sections. The UKMARSBOT one doesn't have any sensors because they're on a separate board. This one has them on the first board, but what you can see is very different is that the HAL has 3 sensors, but it has 5 infrared LEDs. So it's effectively doing the same thing as having 4 sensors, but it's only got 3. Effectively multiplexing the sensors. So it's flashing the LEDs on and off at different times, but using the same sensor. So, that may be a way around the lack of A to Ds that you get in the 2040s and that sort of thing. There are only 3 sensors, but we effectively have 5 sensors that we use. This is another one where we were looking at the side ones. It has a center front one, so it's 3 front-facing sensors because the middle one always works, and the side ones you've got to start sort of poking about and trying to decide whether they're near a side wall or actually seeing a front wall, and it just makes it much simpler to do. Or that was the idea anyway. I mean, whether it's actually useful is a different thing. But it only has 3 sensors, 3 analog inputs with 5 LEDs. So with that, you can still gain all the information that you would if you had 5 sensors. We have AC coupled them. I think that's mentioned later. That's because it's the usual compromise between hardware and software. If you AC couple the sensors, you don't have to read them twice. It's the old hardware versus software. It makes them, I think, easier for, the PIC ones are all AC coupled as well. It makes it easy to explain, so why are you doing everything twice? If you don't, the sensors just give you a value back and that's it. It's not necessarily a better way, it's just a different way. The other thing you can see on there is it has a regulator on the motors. So it's got a 5-volt regulator, which means you don't necessarily need to compensate for the voltage of the battery. It also does have something to read the battery voltage, and that's because we wanted to make it so that you could easily take that out. And in fact, HAL has had that modification, so it's had that regulator removed. So you put the whole voltage, which means you can go a bit quicker. And if you're using LiPo batteries, it's important to know what the voltage is, because you want to be able to stop before they blow up or puff up normally. If they get a bit low, you need to be able to detect that, especially if you're trying to do a kit or something that children will be using. You want it to stop before it blows up, or at least try to. Yeah, so those are the boards. See, they're very similar. The two chips at the bottom are the power for the motors. They're the motor ones. Those are actually normally MOSFET driver ICs. And the reason we used those is if you blow one up, you can pull them out because they're available as 8-pin non-surface mount chips. They've been about forever, and there are half a dozen different companies that all make that same chip. It's like a 555 or a 741 or something. It's a chip that's been available forever and probably will be. So we used those, but essentially they're just bridges, transistor bridges that run the motor in the same way that the Toshiba chip does on the UKMARSBot. So you can see that it's using the same motors, same gearboxes, similar 2-cell LiPo. It was designed to use exactly the same PP9 replacement. You can see on that we've replaced it with 2 cells that are either side of the motors, but it's just still 2 cells that are on there. That's so it fits underneath the cover that we eventually put it on there. The UKMARSBot currently uses the Arduino Nano, which is a nice cheap thing. When it was Mavis, it did use an Arduino Nano clone, but we replaced it with a different clone that has an LGT8F3828, I think it's supposed to have P on the end there as well, processor, which is a Chinese copy of the Atmel chip. But it has certain advantages over the Atmel chip. This is one time when they've cloned something, but they've made it better at the same time. The main thing is it can run at 32 megahertz rather than the 16 that the Atmel does, and it'll also run at very low voltage, so you can run it at 3.3 volts still at 32 megahertz, whereas if you try and run the Atmel, you have to put it down to 8 megahertz. You'll see all the 3.3 volt ones they're all 8 megahertz, and there's a couple of other very, very small differences, but apart from that, we literally plugged that in and it just worked. It's a complete clone of the Atmel chip. Yep, so we got the capacitively coupled sensors, the slightly different motor drivers. If you eagle-eyed on the schematics earlier, you'd have seen that all the LEDs didn't have resistors on them, and that's because we've got LEDs that have built-in resistors. You'd also seen that some of those LEDs were the wrong way round, but we won't mention that one. And also it uses direct inputs for the encoders, not through an OR gate. I'm not sure where that came around, but there seems to be something going on. If you ask how many interrupts an Arduino Uno or Nano has, you get the answer back 2 and that for pins, and that's just not true. You can put an interrupt on any pin using banks of 8, so you get the same interrupt for 8 pins. But using that, you can just directly connect the thing and get rid of the XOR gate, where you could if you weren't using it anyway for your other Toshiba chip. You've used some in there, haven't you? Okay, so that's where it's come from. It's it's an older piece. It's older than the UKMARSBot, but very similar. I think some of the bits were probably discussed when we were creating what's going on. Basically, this is a list. If you look, I don't know if you're familiar with the mazerunner software that Pete did, and it consists of quite a lot of files doing various things. This is basically a list of all the files that we had to change to be able to get this to run. And it looks like quite a lot, but 90% of these changes are almost nothing. They're very, very small. Most of the changes are in only a couple of the files. Yeah, one of the problems is that the user interface is very different. It doesn't have the switches. It's only got one button. So you had to do some things in that to make sure that it would run, and you could start it, and the right LEDs came on, because all of those things were slightly different. Most of them were dealt with in the config. So where the LED that it flashes when it finishes is in there, and most of it was dealt there. So there was a lot of changes in the config, but that was because the size of the wheels are different, the gear ratio. I think we've got a 10-to-1 gear ratio on that, but you can interchange them, and as you can on the MarsBot, decide what you're going to use. So the encoders, there was a very small change to the interrupt routine so that it could use the interrupt on change pins rather than the 2 main interrupt pins. The control lines to the motor controllers were slightly different, so that needed a small tweak in there, but very, very little, almost nothing. Okay, in the sensors, we added which I think has now been ported into the software, a change where it calculated the battery voltage using the value of the 2 resistors and the other bits from the A to D. That's another difference on that chip, is that the A to D is better. It's a 12-bit rather than a 10-bit, but as Pete said, you throw away most of that anyway, so it doesn't really make much difference. Changed the thing so that the button pressed routine came back with the right thing. The UI did. I think all we changed in there was some flashing LED stuff. These 2 bits, the PIC1 bits and PIC1 bits H, they contained the functions that read the sensors from the original software, and that just seemed like the easiest way to do it, because instead of having the XOR chip under the thing, we've got a shift register, and it's a sort of combined shift register latch and also transistor, daunting transistor driver. So it's driving all the LEDs using a SPI directly. So that allows us to have all these LEDs everywhere, and it's got a lot of just single LEDs. So there's about 5 LEDs plus the 5 LEDs that they're actually running the sensors. So that it's basically an output expander. So that running on the SPI. I think we were using something called the fast access macro.h, which does exactly the same as the digital write fast stuff that Pete was using. So just basically pulled that across. I think Pete did that. Converted it because we gave you that software at some point. Because we've been, the whole point of doing this was to go through with Pete to try and make it easier to, so some modifications were made to the software to make it easier to change. Most of the changes that we did are in mouse.cpp and user.h, but most of those changes are to do with trying to make it run faster. Using what's already in mouse.cpp, you could get it to run with almost no change. In fact, I don't think there was any change to actually get it to work. All the changes that we put in there, which I'll go through in a minute, were to just basically to speed it up. Yeah, so this is why we created HAL, or changed it to be HAL. We just wanted to, because we got a very good reaction from people about the Terminator, half-size mouse that we had. So we thought we'd do a similar thing with this to try and promote the software and I don't know, just make it more fun. So none of this helps with performance. It's all completely stops it continuing. But basically, well, some of it does actually. We added an SD card, which is an open log SD card writer, which basically does the same job as the Bluetooth. There is on the original one, there is a Bluetooth socket for one of those Bluetooth adapters, and you could just put that in there. This just logs everything to the SD card instead. The reason that we do that is because it always goes wrong when you haven't got the Bluetooth connected. And then when you try and go back to do it, it doesn't do it. So even in the middle of a competition, if it does something silly, you can go back and look at the log and invariably you haven't been writing what you need to the log at that point, but quite often you can, and you can tell what's been going on. So I definitely recommend that. That is really good. Or its bigger cousin, the Open Lager, which is actually a lot better. It's a lot faster. It all starts getting very silly though, because the Open Lager has an STMF4 on it, doing nothing but logging stuff to an SD card. So you've got an Arduino running your entire mouse and an STM just logging things. We added the voice, which is a DF Player Pro, which is just a little board that can play MP3. It's basically an MP3 player, and a speaker out of a mobile phone, which was put on the top, and you can connect to that serially and control it. So you can say, do the third, play the third track or whatever it is that you want to do. All the voice is AI generated. It's all AI deep fake stuff from various online bits and pieces. So you can get it to say anything, sounding very much like HAL. It's pretty good. They tend to be quite good as long as it says something that you think HAL would say. If you start giving it complete nonsense, then it sounds silly. Yeah, so we've got SD cards, speaker. The top was vacuum molded, which we found as a really good way of, if you want to produce that sort of case. Very light, much lighter than 3D printing it. Some of the details on it were 3D printed, but the main part is vacuum formed on a sort of homemade vacuum former with a Dyson stuck up the end and stick the thing in the oven and pull it out type arrangement. It works beautifully. You create a mould and
Is that 3D printed mould?
The mould was 3D printed. Yeah, we 3D printed the mould, but the mould was much heavier, so you want to keep it lighter, unlike the Mr. Fusion one, which. Okay, so there was some changes that we made to make it more reliable, and some of these changes may end up in the software, some may not. I don't know. We need to go through with Pete and things. as to exactly what's going on. We put the open log thing in to be able to log everything, so you can go back and it literally, we've got one SD card in there, and we've never, you know, it's I can't remember, it's about an 8 gig one, but it's used about 200k and it's got 400 runs in it, you know, so you can go back anywhere to look at what you know, what happened in an earlier one. Yeah, the 5-volt regulator we removed so that it could use the internal compensation properly, mainly because I was interested in how that worked and what it was doing. But I think it helped. I think it means that you can get a slightly higher top voltage to the motors. But again, it shows, you know, there's more than one way of keeping the things regulated. The important thing is that they are regulated, and that makes a big difference. Okay, we did the increased speed on long straights bit, so it works out how far ahead it can go that it knows, and then just goes the whole distance. So in the software you can just say go 1.5 meters forward or whatever, and that's exactly what it does. And it was it's the same routine that we used to increase the speed, but of course it has to go through each of the things, so it ends up with the address of where the end of the straight is, you know, conveniently, that you can just use to say where your mouse now is once you get to the end of it. Low battery detection, that's something that ought to go in, I think, into the standard software so that it will turn off when the battery gets low. Do you I've seen a couple of times where your mouse seems to have stopped halfway around a run because the battery's low. Pausing for breath. We only check the battery at the start and the beginning, because we just sort of say, well, if you're halfway around a run, you might as well keep going. Yes.
Yeah, what happens with decimals is it'll sometimes stop with a low battery because it's trying to do something smart, trying to put its foot down and accelerate.
Right.
The battery to dip. If it dips for more than some significant fraction,
It just stops.
It just gives up rather than doing that.
Right. Yeah.
But
So.
it probably have carried on for some time, travelling around at lower speed.
Yeah.
You've got to remember that decimals puts a significant strain.
Yeah, it does. Yeah, because it has those very low voltage motors as well, which are low resistance.
They're 3-volt motors driven at 7 volts, and if you don't take care of the battery, you will get some pleasant.
Yeah. Okay. Crash detection. It has very, very crude crash detection, but it does work. Basically, it looks at the error in the feedback, in the loop, and if the error gets too much, it just gives up. And you need to set that so that it can do quite a bit of crashing before it actually does it. But it's worth having some sort of decent crash detection, because your mouse can not only ruin the map of the maze, it can ruin itself, crashing round into things, or even ruin the maze and get you thrown out the competition altogether.
If your error detection is done like that, by monitoring, this is the control error, right?
Yeah.
One side effect, which is a benefit, is that you can grab it, hold,
Yes.
and after a while it will give up.
Yeah.
As opposed to grabbing it, hold, and then fighting it like a little kid.
Yeah. Yeah. If you pick it up and you hold the wheels to stop them from turning, it'll just stop. And of course that helps not kill your motor controllers and your batteries and your motors as well, which can all, end up burning if it actually gets stuck somewhere. So that's probably another thing that's really worth putting in there. Another thing that doesn't appear to be in there and isn't on this list is impossible maze detection. So it will detect if it can't get to where it's trying to get to. via the maze, and it.
Should be doing that.
Yes, well, it's not. It's not in that software.
It doesn't work.
Yeah.
It just classical.
All I do for that is if you just work out where you are and it ends up as 255, that's the value that all the that's put into the whole map at the beginning. Then it hasn't got there. But what you've got to remember is that you don't want to automatically reset your map or anything there, because just because you can't get back to the start doesn't mean you can't get from the start to the middle once you put it back at the start.
You may have all the walls around you, think you have no solution, but there's actually plenty of solutions left, so that you can just stop, shout out, and just put back at the start.
Yeah, and it may then work. Okay, it has very crude edge detection. I don't know who's seen the run that was in the US, but you'll see it going up those straights on its fastest, which I don't think that was the fastest run, but you'll see it crashing into walls, going all over the place, but it still ends up at the other end in the right place and goes around the corner. And that's because it knows it's a big long straight, and it knows it's got to turn at the end. So when it gets there, it says there's a wall, we haven't seen that edge where you can turn. So it just keeps going, and it ends up in the right place. So the edge detection is extremely useful, just to make it much more reliable. And it did that several times on that run, and it cannot work. It depends, if it's going up and crashing into walls and there happens to be a gap there and it smashes into it, you've had it. But quite often a long straight will have walls down either side. So it's definitely best not to do that, but that's what you would use. So by edge detection, I mean detection of the posts, which was talked about earlier. It knows that it does, if it can't turn until it's seen that post. But it's very, very crude. It literally just says it has a flag that's deciding whether there's a wall on the right, and it looks at the last one of those and the current one of those, and if it had a wall there before and it doesn't now, it decides that that's where the edge is, and that can very easily be wrong. You need to look at it. That's something that's quite important, and definitely needs a bit of work. But it's better to have something rather than nothing. It can make a very big difference. And HAL can go, because it's going left and right, it's working out the distance. But of course, if you look at the distance, it's gone a lot further. It's a lot further doing this than it is going straight. So it can literally be cells out at the end. And if you've just got a good part like that, it's quite useful to do.
Where somebody's so to catch anybody who does that.
Yeah.
And so around the outside, they had 15 long straights, 15 cell straights, and then a little hook arrangement at the end, right? So there was a little one cell dead end just before the turn. So anybody who was getting
doing that, yep.
And finished too soon,
yep.
And waited for that edge, just dove straight in there.
Yep. And how certainly if it was bashing into the walls, would have done that. But that wasn't there. So, sometimes it helps. That's what I mean by it needs to be less crude than we've currently got. Okay, you'll see it if it goes into a dead end. It doesn't just turn around; it turns 90 degrees, and then it can use the front sensors to make sure that it's in the middle. Then it will turn around, and then it does the backup, which Pete was talking about earlier. It's not HAL, it's Mr. Fusion, I think, which has got two lollipop sticks or something stuck on the back, so then it ends up bashing into the wall straight. The other thing we did was to remove, you've got that high speed searching thing in there where it searches at a slightly higher speed, and then just before the corner, it, in the last centimetre, it decelerates very quickly and loses a...
Yes,
Yeah.
It's completely contradictory to what I said earlier, which is to run around at the same speed.
Yeah, that bit. We removed that and used that space for more correction, so that it was able to correct bigger errors when it had gone in. That's just a reliability thing, and of course you don't really lose anything for slightly slower searching. So what happens in the UKMARS software is that it goes around a corner at, I can't remember what it is, but say it's 100. It goes around the corner at 100, but when it goes onto the straight, it will increase to 150, and then a centimetre before it gets to the next corner, it'll slow down very quickly to the corner, and that improves your search because you get to go along straights that you haven't been along a bit faster.
It is calculated to be able to get down to the speed.
Oh yeah, absolutely. Yeah, it'll do it.
Probably
Yeah.
without taking out.
Yeah. We basically use that same distance to be able to move the mouse backwards and forwards a bit on the corner so that it's in the right place. Not that works hugely well, but it works okay, I think. Okay, and that led to us winning the competition in the US somehow. Basically by being the most reliable mouse there. So don't give up. It can happen, even when you're in a competition that's supposed to have 27 3-second mice. They can still win. Yeah, and it was the only mouse that did a complete run of all its fast runs without being touched. And in the US, they have a touch penalty, so it got 2 extra seconds for that. They have this odd one where it's not a penalty, it's a bonus. So if you haven't touched it, you get 2 seconds taken off your time. But it's the same thing.
No, it's just, you can pick it up at any time.
Yeah, any time at all. So yeah, including cleaning wheels or anything. Anything at all, you lose your 2 second bonus. Yeah.
Does that get in between runs?
Yes, you're not allowed to touch it. And it was the only mouse that did all its runs, which is not always good because I always expect that some run is going to crash. And it did its fastest run and didn't crash. Though it did keep trying to go on after the thing. There was a bug there.
Talking of which, we are horribly
all right.
overrun.
That's good because this is the last slide.
Thank you for that.
Okay.
And it's good to see the software being used elsewhere. It's not UKMARS, not just about
Yeah.
UKMARS, not just about the hardware, it's also about the software. The software is there. There is currently a revision of it in progress, incorporating some of these changes and simplifying what I know is not
Right.
a fantastic
Okay.
piece of code. And when we're ready with that, we'll
Yep.
kind of move that up onto the UKMARS site and make it more available.
Okay. And that's the code that's running in Mr. Fusion.
Right. So that's called mazerunner core. Anyone who wants to help with that, get in touch.
Yeah.
One of the
Anyone else?
purposes of mazerunner core is to allow it to more easily be ported to a different processor. So if you want to put an arrow library on it or STM32 or whatever, that's
Yeah, Mr. Fusion is using the Arduino BLE33. So, yeah, so it's using a completely different processor.
All of those Nano 33 alternatives are valid targets. So if anybody wants to help out, Arduino, because I've got arrow irritating